I'm Patrick Bergel. I'm the founder and head of product at Chirp. Chirp is a platform for exchanging data using sound. What we do is create a sonic link, a very small amount of data, just 50 bits, passed over the air as sound, as a series of 20 sine tones, which we then decode on a device, on a more powerful device like a mobile phone, or we can encode it on a simpler device like an Arduino. The reason we moved to Arduino and embedded hardware is that Chirp was always intended to be a platform for very general use. So mobile phones are kind of a relatively fun and unconstrained dev environment. They're pretty powerful these days. But what we want to do is make Chirp work on lots of very cheap, simple hardware so that the technology can be available for the Internet of Things, for connected devices generally, because we see a real place for sound as a connecting protocol between devices. So Chirp is designed to be a very simple protocol to implement. The first 2 notes of any chirp, which lasts, a whole chirp is 1.8 seconds. The first 2 notes are a front door. The next 10 notes carry 5 bits per note, giving us 50 bits, and the last 8 notes are error correction, so that we can recover the signal if it's in a noisy environment. But we use simple sine waves. Chirp is monophonic, so very simple devices can encode chirps. Decoding it is obviously out with the scope of simple embedded hardware. We need DACs, we need to do multiple Fourier transforms, which is not always possible on the low-end devices. But something as simple as a doorbell can certainly send data, and that's a pretty exciting idea to us. So we like to think of chirps being embedded in toys. Chirps can of course be embedded in any kind of dumb audio player and played over any kind of regular loudspeaker to trigger some kind of action, usually to open a link of some kind, but really it's just a sonic trigger. And it's up to developers to find cool uses for our technology. What's quite exciting is that teachers are using Chirp a lot in classrooms. Chirp's been installed on 40,000 devices in California schoolrooms. Teachers are chirping class notes to kids, which is great, because we didn't design Chirp for that. They had a problem, which is lots of kids who can't type very quickly, or maybe can't type very well, and it's the easiest way to get everyone literally on the same page. So what's cool is that we've been winning EdTech prizes that we haven't even entered, and that's very exciting. That kind of validates the kind of platform play, what we want to do with Chirp. The Bitcoin community have kind of taken an interest in Chirp, which is cool. We had a Canadian radio station that broadcast an open Bitcoin wallet over the air. That was the first known broadcast of actual currency on the radio. So we could have made Chirp a lot faster, but then it would have been way uglier. We could have made Chirp sound a lot more like a modem. But remember that modems are designed to really carry sound down the wire and not over the air. They're not designed for the kind of distortion and echo and reverberation and other kind of noises that one would find in over the air. So one challenge was to make it robust as a protocol, to make sure that it communicated data relatively efficiently over short distances. The other challenge was to make sure that it was outside of the normal either time bases of music and speech, and also out of the same kind of frequency range as well, so that made the decoding job a bit easier. But the last part was really thinking hard about, you know, what could a sound be, what would machines sound like if they wanted to talk to, and we think that Chirp is just the beginning of a whole set, I hope, of sonic languages for the Internet of Things for connected devices. So we're often asked, could Chirp be an ultrasound? The answer is yes. We have lab versions that work inaudibly. Could Chirp be different textures, different tones, timbres? Could you have a Chirp in waltz time? Why not? Could you have a Chirp that was blues in E? Okay. So these are the kind of ideas that get me very excited, and hopefully will be part of the next phase of Chirp. So what's happening right now is we are about to try to raise some money from the crowd, from crowdfunding. We are just about to launch a campaign on Crowdcube, and we are looking for the support of the crowd to take the business forward, to make what we're doing come true. So Crowdcube is an equity funding site, so anyone who puts money into that campaign will actually own a share in Chirp. So for as little as £10, you can own a little slice of the business. So the reason we went with Crowdcube rather than Kickstarter is that Crowdcube is much better geared to what we want to achieve. Kickstarter tends to be product focused and not really the right venue for investing in a software company. So the reason why we think Chirp is an interesting investment opportunity is the fact that Chirp is already being tested by large financial institutions, global telcos, as well as small developers just wanting to play with it. So there's been a considerable amount of interest in using Chirp in zero network environments where the data is preloaded onto a device and the Chirp is just used as a trigger. And there's obviously considerable and proper consumer resistance to QR codes. Maybe people don't have fancy phones with NFC, which is certainly the vast majority of the world. There's been a lot of talk, of course, about beacons, but again, that's sort of a fairly niche thing at the moment. So Chirp goes where other networks don't. That's a powerful technology, and that's why we have some significant interest in licensing our SDK and putting it into other people's applications. So just last week we launched our SDK program in private beta, so if you hit us up you can get an invite to the program if you wanted to build something with Chirp technology in your application. I think probably the best use for Chirp at the moment is a human-to-machine communication rather than just machine-to-machine. There's lots of great ways to move data between machines. We're not trying to replace that, but we are trying to be part of the whole ecology of connected devices. You might want to use Bluetooth LE, that's fine, perfectly reasonable. Chirp has different affordances. It is detectable and distinctive as a chirp, so it tells a human being rather than a machine that some data is being passed. We may decide to characterize the chirps so that they're much more readily identifiable to humans. So we think that there will probably be a human in the chain, or at least supervising the chirp experience. Machine to machine is not directly the goal. Obviously, sound is a kind of much underappreciated medium for moving data. We see ultrasound is being used obviously in imaging, in engineering, in communications, and there are places where that sound is the most appropriate way to detect a structure or even send some information. So how does Chirp work in noisy environments? So Chirp is very resistant to noise, to speech, to traffic sound, to music, but Chirp is not resistant to other chirps. So if lots of things are chirping at the same time, then the decoder has some problems. We do have some ideas around that, but that's not a problem we're looking at very hard at the moment. We don't expect to have multiple devices chirping at the same time. Obviously, one of the fun things about using sound is it's a one-to-many or one-to-few kind of communication. It allows everyone in a room, for example, or everyone around a table or in a classroom to receive the same data. So that's one aspect of Chirp that we like. It's a headless system. We don't care who's around. Just as long as they're in proximity, you can still address their device and still send them some data. Our goal really is to teach the machines to sing. We want to create a whole set of sonic languages for devices. And Chirp, we hope, is just the first step towards that.
Awesome.